Jim McGregor here with Sirius Research. We're at Embedded World here with Micron. Puneet, you're going to actually walk us through DLEP and tell us a little bit about first what it is, and then kind of show us the demo on the benefit of using it.
Absolutely, my pleasure, Jim. Innovation at Micron has been one of our legacies, and we're super proud to show a DLEP feature here on our latest LPDDR5X memory based out of our latest node in Micron. DLEP basically is direct Link ECC Protocol. As you know, in memory, we have to manage all the redundancies and ECC around it. In this feature, and that's at the product level and at system level, what Micron is now enabling is to empower this whole AI at the edge journey that we're going through and enable more bandwidth to the system. We're offering an ECC that system can use, and what that allows you is additional bandwidth. And I'm here ready to show you a demo here. On a DDR5, this set is without DLEP, this is with DLEP, and we have the system right here, which is kind of taking both those memories together. And if I do a sequential read run with and without DLEP, as you come close, you would notice here, it shows you the improvement of 28% on sequential reads with and without DLEP. So that's the feature that enables data centers and all the latest and greatest. And I have a similar thing on sequential writes. We can read on that simulation. There you go, 51% improvement in sequential write. That is a real deal breaker, and that is driving a lot of excitement among all our customers to use this feature and enable the next generation of solutions.
And that's not just an increase in performance, but that's also an increase in efficiency. So, I mean, we're also talking about reducing power consumption to execute all these things. So I would estimate that the power execution is also about that same savings.
Absolutely. I mean, the biggest bottleneck in the growth of data center and server markets today is power and power management. And this will definitely be an incredible driver and enabler of that low power.
Here with another demo at Micron at Embedded World. And Puneet, you're going to tell us something about memory built-in test. I guess this is a feature I don't even know about. So let's find out about it.
Absolutely. So as memory continues to grow and memory density continues to grow, what's not changing is the error handling and the amount of error that's acceptable in a system. So that continues to even go down as the density continues to go up. So the innovation team at Micron continue to look at ways to improve it. One of the features that we have introduced is called Micron built-in self-test. What this does is, this is a status report, but there are 4 banks of memory you see, and we're going and doing this own scan and self-test in the idle time of the memory. And as we find some memory bit that is not meeting our highest standards, we went and go and self-repair that, or we find redundancy remapping of that word line to make sure at system level there is never an error around memory. So this is all self-done in an idle state, memory auto-correcting itself just to make sure it's ready to perform when it's really needed.
And I would assume that if it can't be corrected, that it would just map that out so it doesn't try to get used again.
Absolutely. So we will go find another redundant place in the memory where we go store that information at that point. So never lose it.
That's awesome.
Yeah.
And this is available in all the memory solutions from Micron?
This is on our latest LP5. Yes, this is a feature that we are offering.
That's awesome. Thank you.
Yes, you're welcome.